problem. Suppose a group of students collected and analyzed data and found that the number of hours per week that a college student studied and the student's final grade point average could be modeled by this function. In this expression, age represents the number of hours studied per week, where age can take on any value from 0 to 30. Another group found that the relationship between students' final GPA and their first salaries after college could be modeled by this function, where G represents the GPA and can take on any value from 0 to 4. Now, in our GPA equation, it seems like the number of hours is dependent upon, your GPA is dependent upon the number of hours you have studied. Of course, the higher the number of hours you studied, the higher your GPA, okay, because they are directly connected. But of course, there are some students who actually don't study, but they could get it. Hats off to them. And it also shows that your salary is dependent upon your GPA. It could happen in real life. There are some employers who want employees with good point average, okay, like what you have here. Now, in the context of the problem, consider the meaning of the composition of these two functions. So what is the meaning of that? As I've said before, the GPA will be your inner function because that is the independent variable, and your salary is your outer function because that is your dependent variable. The salary is based on the GPA, so it's only fitting that the GPA will be your inner function. Okay, now we would like to write that composition because that says it. So you have now your salary as being the dependent function based on the GPA, G of H. And that is our composition. Now, if we do that, we will write first our outer function, which is 6 times 2.7G plus 3.8 raised to 3 plus 10,000, 10,500. And we will replace our G with this value. Okay, so therefore, this now becomes 6 times 2.7, the square root of 0.5h plus zero point 0.9. So this is now with respect to the number of hours studied, okay, instead of using the GPA, plus 3.8 raised to 3 plus 10,500. Okay, now you're asked to find the domain of the composition, but it's actually given to, in the context of the problem, it says that the value of h, which is your x in the composed function, is between 0 and 30. So therefore, our domain is that our x is greater than or equal to 0 but less than or equal to 30. Okay, so if it's greater than 0, so it goes to the right side, and if it's less than 0, it goes to the left side. So it's actually a union between 0 to positive infinity and then 30 to negative infinity. So that's our domain if you write it in the interval. So it's greater than 0 but less than 30. That's the meaning of that. Now, you're asked to find out what will be your starting salary if in your college days you studied 25 hours per week. Okay, that means a good GPA because 25 is near 30. So, therefore, we will plug in the value. We can also make use of the original equation if you want that. Plug in first 25 here and then plug in whatever you get here. So we will do both so that you would see how they differ and how they are the same. Since I already have the composed function, I can replace age with 25. So that will be 6 times 2.7, the square root of zero point 0.5 times 25 plus zero point 0.9 plus 3.8 raised to 3 plus 10,500. Okay, so let's see that. So this will be using the calculator 6 multiplied by 2.7 second x squared, and you have 0.5 times 25 Okay, and then plus 0.9. And you have to put the cursor outside, plus 3.8. Close it, and the exponent is 3. Then, of course, you will still have to add 10,500. So this is our y-intercept. Okay, it means that should it be that your GPA is 0 and you are hired, your starting salary would still be 10,500. Well, of course, you don't want that. So enter that. So the starting salary is 25,872 point $86. That's an approximation. Okay, now I told you you can also do it using the original equation. So our age is 25. So we can plug in 25 in here. So that's 0.5 times 25 plus 0.9. Let's do that. Okay, using our calculator. So second x squared, that's 0.5 times 25 plus 0.9. Okay, and that is your x. It's approximately equal to 3.661. So your x here is 3.661. In the context of composition of function, this will be now the x in your outer function. So g now will be replaced by 3.661. And we are expecting that our answer is very near to 25. If not the same, it's going to be very near to 25,872.86. So let's do that. So use following this when x is 3.661. So that will be 6 times 2.7. All right, and our G is 3.661. Okay, plus 3.83, 3.8. Okay, close it. The exponent is 3. And then you will add 10,500. And let's see if you will get the same answer. So add 10,500. And enter. And as you can see, as I've told you, because we actually rounded off from 0.6, okay, from 0.6, we opted to use 1, and as you can see, the numbers are relatively the same. So it's either you make use of the composed function or you make use of the original functions by switching the plugging in. So the process of composing function, your answer would be the same. So remember, when you're solving problems, the first thing that you have to think about is what is my independent variable? And that would be your inner function. So in this situation, the independent variable is GPA because the salary is based on it. The outer function then becomes your salary. And from then on, you develop on how to solve your problem, you make your strategy. It's always important to know your domain because it will give you the restrictions for the values of x. So in this situation, you are restricted that the number of hours studied per week is a maximum, it's a maximum of 30 hours and of course a minimum of 0 hours. And that's it.